All right, chapter 16, we're going to talk about compounds that have the carbonyl group. All right, so the carbonyl group, remember, is a group where you have a carbon with a double bond to an oxygen. All right, it's called a space filling model. You see this a lot in the book, where they're just kind of showing you like different colors for the atoms. But basically, the carbonyl, remember, based on electronegativity, oxygen has a partial negative charge, or your carbon has a partial positive charge. Okay? So, the first two classic compounds we'll talk about are aldehydes and ketones. Remember, an aldehyde is where you have some sort of carbon R group with the carbonyl and a hydrogen on one side. All right? The easiest way I remembered it is that aldehyde has an H in it, just like an aldehyde does. And then ketones have two R groups. They can either be the same R groups, and remember, R groups are basically anything that has a carbon and hydrogen on them. All right, just to remind you that. They could be the same R groups, like acetone. You have a methyl group here and a methyl group here, or you can have two different R groups as well. Okay. Other compounds that have carbonyls are carboxylic acids that have an OH next to the carbonyl, and ester has an OR group next to the carbonyl, and amides, various types of amides. We'll talk much more about these when we get to the biochem chapters. Okay, carbonyl compounds are trigonal planar around the central carbon, so all the bond angles are 120 degrees, and like we said, it is definitely a polar bond. Okay, oxygen is more electronegative than carbon, so the carbonyl is polarized with the partial negative on the oxygen and the partial positive on the carbon. We just talked about that. All right, structure and bonding. This is kind of the condensed way of drawing an aldehyde. You write it as CHO, which implies you have a carbon with a hydrogen attached to it and an oxygen. And ketones are sometimes written as you have the group plus CO plus a methyl group. All right, or if you have the same groups, you can do like CH32CO. Remember, I said in class I don't really particularly like this method. These I also really don't like to write them. I like to draw out the actual structures. All right, so I would get in the habit of drawing out the structures like that. Okay, naming aldehydes, very simple. You basically look for the longest chain that has the aldehyde group on it. The end of your parent chain is named al, so if you have 3 carbons, it's a propanal, all right? And the aldehyde group always gets carbon 1. That is always carbon 1, and you apply all the same rules, okay? So, pretty simple. Here's an aldehyde. This is carbon 1 automatically. So this is carbon 2, this is carbon 3, this is carbon 4. Okay, so it's it's a butanal. Now you do not have to write the 1 because the 1 is always carbon 1. So if this is carbon 2, carbon 3, this would be 2,3 dimethyl butanal. 2,3 dimethyl. I'm having a hard time writing it, but we'll see the answer in the next slide. All right, 2,3 dimethyl butanal. This one, the longest chain, see if you can figure out where the longest chain is as the aldehyde. Well, this is carbon 1, this is carbon 2, this is 3, this is 4, this is 5. So it's a pentanal, 2-ethyl pentanal. All right? So here it is on the slide. Here's the longest chain, just like we said. It's a butanal. Here's a pentanal. All right? And you have a 2,3 dimethyl butanal, and here you just have a 2-ethyl pentanal. Pretty straightforward. Okay, actually I think it's easiest to name the aldehydes because you know where carbon 1 is. You don't have to figure out where carbon 1 is. Alright, these are some of the most common aldehydes. They actually have aldehyde in the name rather than an al, so formaldehyde is where 2 hydrogens. Acetaldehyde, this is what you form when you oxidize ethanol in the body. And benzaldehyde. All right, benzaldehyde actually has almond smell to it. It smells a lot like almonds. That's because this is one of the main components in almonds. It gives it that classic almond smell. Ketones, naming, very simple, just like aldehydes, except you're going to end it in -one. Okay, and you look for the longest chain, and you start counting on the side closest to the carbonyl. So that's what that says. The number of the chain which gives the carbonyl the lowest number. All right. So here we have a ketone. All right. The carbonyl is closest to the left side. So this is carbon 1. This is 2. This is 3. This is 4. This is 5. You need to tell the reader where the carbonyl is. So we have 3-methyl, and then it's a pent, and it's a 2-one. 3-methyl, pent, 2-one. All right. And we'll see it in the next slide. For cyclical compounds, this is always carbon 1. Okay, so this will be 2, this will be 3, this is 4. All right, you don't need to tell the reader where this carbonyl is because it's always on carbon 1 in a cyclical compound. So 3-ethyl, 4-methyl, cyclopentanone. I'm sorry, cyclohexanone. Okay, so like I said, here's your 5-carbon chain. This is carbon 2, this is carbon 3. All right, this is a cyclohexanone. This part of it is a cyclohexanone. So 3-methyl, 2-pentanone. You can also name this 3-methyl, pent, penta, 2-one. That's another way of doing it. All right, depends on which way you like better. Neither one is more correct than the other. They're just two different ways of doing the same thing. You can put the 2 in the middle or just put the 2 at the very beginning. Okay, and this one, like we said, 3-ethyl, 4-methyl cyclohexanone. Carbon 1 is always the carbonyl, so you do not have to say it in the name of the compound. Okay, here are some common ketones. The IUPAC name is 2-butanone. And this is called ethyl methyl ketone. I'm sorry, 2-butanone is the IUPAC name, but people call it ethyl methyl ketone. Okay, or actually for short they call it EMK. Because it's a very common ketone, so some people call it EMK for ethyl methyl ketone. Okay, acetone, that's a very common name, acetone. Technically, this is called 2-propanone. 2-propanone because carbonyl is on carbon 2 and it's 3 carbons, so 2-propanone. Acetophenone is a very common one, and this one is benzophenone. All right, some physical properties. They're very similar to hydrocarbons, but they're a little bit more polar. So they form a little bit. So they kind of form, intermolecular forces, more of like a dipole-dipole forces. But they're very similar to their corresponding alkane, with a little bit higher of a boiling point because of the fact that it is a dipole-dipole. It is a polar molecule, so you can kind of see that a molecule that has about the same mass of its equivalent hydrocarbon has almost like a doubling in its boiling point, because you kind of have a partial positive on the carbon, all right, and a partial negative on the oxygen, so you have a dipole-dipole bond versus a van der Waals force. Okay, but they're definitely still lower than alcohols because alcohols have hydrogen bonding. Even though carbonyls can hydrogen bond with water, acetone is actually soluble in water because it can form a hydrogen bond with water. But with itself, acetone itself, obviously it's not as strong as if you have a hydrogen bond itself. So again, you can see the equivalent mass of an alcohol has a much higher boiling point than its corresponding carbonyl compound. So they do not have a hydrogen bond. They cannot form intermolecular hydrogen bondings with each other. If you have water in here, then you can form hydrogen bonding. So they have much weaker forces than a corresponding alcohol. All right, aldehydes and ketones are mostly soluble in organic solvents unless you have less than 6 carbons. So, 6 again is on the high end. I'm not sure why your book does this. In class, we talked about 4 carbons. So I'm going to, just so there's no confusion, somewhere between 4 to 6. Okay, it all depends on the molecule, but there is no exact rule. It really depends on the molecule. But roughly, small molecules are soluble in water because they can still hydrogen bond. Anything larger than 6 will be insoluble in water. So you can kind of see a hydrogen bond here with acetone. Acetone only has 3 carbons, so this for sure is, acetone is pretty soluble in water because it only has 3 carbons. Okay, I'm going to stop right there for these slides, and we'll start back at 16.4 on the next slide.